In previous videos, we looked at the three kinds of transforms that processing makes available to us: translation, rotation, and scaling. We also looked at the transformation stack, which gives us a kind of save-undo mechanism. In this video, I'll show you some examples of using the transform stack, so you can see why it's such a useful thing. Here's a little program that uses just about everything we've seen this week. Each leaf, when it's first made and when it's restarted, is described by a bunch of random numbers that come from ranges that I picked. To save all of those random numbers for each leaf, I use a bunch of arrays. As the leaf is falling, sometimes I change the random numbers that describe the leaf. This means that the leaf's motion can change several times as it's falling, which gives the whole thing a little bit more visual interest. To draw each leaf, first I translate to the center of where it is at this frame, then I scale it because some leaves are big and some leaves are small, and then I rotate the leaf. After I draw each leaf, I update it. I move it a little bit in X, I move it a little bit in Y, and I rotate it a little bit. And this will run forever, and it will never generate the same image or the same animation twice, because everything is being controlled by random numbers. There are three fixed elements: the brown tree, the kind of pumpkin orange canopy, and a very little bit of ground at the bottom of the screen. Let's take a look at the code. Conceptually, we can think of this program in four pieces. There's the setup piece, the draw piece, there's the part that defines the shapes, and then the part that draws the shapes. I've organized all that stuff into two files. This file contains the setup and draw routines. The other file contains the XY coordinates of the shapes and the routines to draw them. Let's look at these fairly quickly. Here at the top of the file, we can see declarations for 8 different arrays. 7 of them are floats, 1 of them is a color. In other words, every leaf is defined by 8 pieces of information, 7 floats and 1 color, and so we have an array which has a list of those values for the list of leaves. So for example, if we have 100 leaves on the screen at once, then the 15th entry in each of these arrays describes the 15th leaf. The first 4 arrays tell us the leaf's center in X and Y, the radius. If we think of the leaf as sitting within a circle, this is the circle that just barely encloses the leaf. And then we have the angle at which the leaf is turned as it falls. The next 3 arrays control how the center X, center Y, and angle change from frame to frame. The values in these 3 arrays are just added to the center X, center Y, and angle on every frame, and that causes the leaf to move and rotate as it falls. Finally, of course, every leaf has its own color. To make it easy to control how many leaves are being shown, I've created a variable called numLeaves, and that just tells me how many leaves to make. That's it for the global variables. Let's look at the code. We begin with setup, and it does the usual things: creates a graphics window, calls smooth, and then I call a routine called create new leaves. That builds the arrays and fills them in for the first time. So let's take a look at that routine, and luckily it's the very next one. So here's create new leaves, and you can see that the first 8 lines just create the 8 arrays. They all have the same length. They're all num leaves long. The last 3 lines run through a little loop where I just call restart leaf for every leaf. So far, all we've done is we've built the arrays, but we haven't put anything into them. Now we need to actually fill in the leaves with some values. So I have a routine called restart leaf, which takes a single integer, and it fills in that leaf with a new set of starting values. Let's take a look at that, and it's actually next in the code. Here's restart leaf, and you can see all it does is it puts random numbers into each of the entries for that leaf. All of these numbers are hand-tuned. I picked something arbitrary in the beginning, and then I just adjusted them by hand until the resulting motion when I ran the program looked good to my eye. Notice that when I choose my color, I go into HSB mode. That way I know I'm always going to get colors between orange and yellow, with different saturation and brightnesses. If I tried to pick my colors using RGB, it would be much harder to make sure that they always came out between orange and yellow. Now we're ready to take a look at draw, which is next. Here's draw, and you can see it does 4 things one after the other. First, I call no stroke and background to set things up, and then I draw all the leaves. I call 2 routines, one called draw leaves and one called update leaves. Draw leaves draws all the leaves, and then update leaves moves them. We'll see them in a moment. Once the leaves are drawn, I draw the canopy of the tree by filling in with an orange color, and then I call this routine called Draw Shape, and I hand it Canopy XY. Canopy XY, we'll see in a moment, is just a big list of X and Y values, and Draw Shape just wraps up those X and Y values between begin shape and end shape, and we'll see that in a moment too. I draw the tree in the same way, except that I draw the tree vertices, and then I draw the ground, which is just a big ellipse. So let's take a look at Draw Leaves. This is the heart of the program. It starts out with a loop that runs through all the leaves. So I run I from 0 to the length of one of the arrays. And I know all the arrays have the same length, so I'm going to use the length of leaf center X arbitrarily. We can see that for each leaf, I'm going to do some translating, rotating, and scaling. And I always want to do that with respect to the default coordinate system. So the first thing I do is I push the matrix. I set myself a save point. I draw the leaf, and then I restore the way things were before I made any of these changes. What are my changes? Well, they're perfectly straightforward. I translate to the center X and Y. I scale by the radius of the leaf. I rotate by the current rotation of this leaf. I fill with the current leaf's color. And then I call this routine called Draw Single Leaf, which is just like the other draw shapes, and we'll see it in a moment. It just does a little bit of scaling to make the leaf the right size. Once I've drawn the leaf, as we saw, I pop the matrix, and then I go back to the loop and I draw the next leaf. Once all the leaves have been drawn, we call Update Leaves. Here's Update Leaves, and we can see it begins with another loop through all the leaves. First, I update the X value by adding the frame-by-frame change in X, or which I'm calling speed X, to center X. I update center Y as well, and then I update the angle. Here's a fun little thing. Every once in a while, as the leaf falls, I decide to change the numbers that get applied to the update. So it might move a little differently in X and Y and angle. Now I don't want to change it on every frame because then it'll just look like it's jittering. So I roll a random number between 0 and 1 and I test it against 0.97. That's definitely a number I chose by hand. I sat there and just made that number bigger and smaller until it looked to me like the leaves were changing at a rate that worked for my eye. If we think about it, the random numbers are going to come out between 0 and 1. That means this test will succeed about 3 times in 100. So it's a very infrequent kind of a thing, but it's frequent enough that we can see it. When this test does succeed, I just put new update values into the 3 numbers that control the X, Y, and angle change. Then finally, I test to see if the leaf has disappeared off the left side, if it's disappeared off the right side, or if it's disappeared off the bottom. And if it has, I call restart leaf and put new values in it, and it starts all over again. This wraps up the first file. In part 2, we'll look at the second file holding the routines that draw the elements of the picture.